Corporate Finance practice problem using Excel. We're going to use the future value calculation to figure the rate, in other words, the investment rate of return. Get ready. It's time to take your chance with Corporate Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being the answer key. We're going to have the information up top on the left-hand side. We'll put that information into the blue area on the right-hand side, including a mathematical formula, a running balance, an Excel function, and then use of the tables, ending it off with the table time. Going back to the left-hand side, our information then is... we have the purchase of stock. We're going to imagine a purchase of stock situation. Shares 200, cost $20. Some point later, 3 years later to be exact, the stock is sold at a price of 31. Our goal then is to look at the rate of return in essence, and we want to do that using the future value type of calculation, which means that we're going to have to basically kind of back into the future value calculation. In other words, use the future value calculation here to calculate then the rate, which is going to be R. Let's first multiply this out to see what the purchase price is. I'm going to say this is going to be the 200 times the 20. That's going to be 4,000. And then we sold it down here. That's the purchase price. We sold it for the 200 shares times the price of the 31. And that's going to be the 6,200. So we can plug that then into our formula if we have the present value. So we're looking at the future value formula and then solving for R. So we have the present value, which would be the 4,000, and then the future value, which is the 6,200. So if we were to do the algebra then, we would have the future value, which is going to be the 6,200 equals the present value, which would be the 4,000 times 1 plus R, R being the unknown, to the power of the number of periods, which in this case is 3 for the 3 years, and then having the only one known and one unknown, that being R, or the rate, is what we can then solve for, and we can kind of back into the rate. Note what we're doing here is we're using the future value formula, and instead of us basically trying to memorize another formula to basically come up with the rate, we know that we can use the same formula with algebra and then solve for the unknown in there, in this case that being R, the complicated or difficult component often being when or which formula can we then use for a particular type of problem here. So we're going to use the future value formula here to back into the rate being the unknown. Now also note you might want to do this with an Excel function using the same kind of concept, but it being a little bit more difficult. Very good concept to have to understand, so we'll practice it a few different times. If we jump over here to the formula format, for example, if I jump over here, we're going to do the Excel formula a little bit later, and if I look at that future value formula, if we take a look at the good old future value formula, then we have this setup here. Now this isn't an algebraic equation, so we can't really use the same logic. And if we get to longer types of formulas, then we want to use the functions here, but we can't really solve for an unknown that isn't the end result because it's a function, not exactly algebra. But we can use it like a trial and error method, a goal-seek type of method to utilize the concept of algebra in a similar way. Then, in other words, if we have one of these components, rate, number of payments, the payment, and so on, that is the unknown, and we only have one unknown, we can basically use trial and error or the tool of goal-seek in order to back into it. In order to get that concept down, let's do that a few different ways, and we'll start with a mathematical formula. So one, you can plug it into this formula and then solve for R. I won't solve for R now. You can do the math and solve for R. I'm going to put it into our table type of format here as we normally would put it, and then just think about how we would use goal-seek. Then we will apply that concept to the actual Excel formula as well. So we're going to say the present value is going to be the 4,000. You may also be able to use the actual just the cost, since we sold all the shares of the 20 and the 31, but I'm going to use the total amount, the 4,000. And then we're going to pick up the 1 plus R to the n. That's going to be this amount down below. So we'll pick up the 1, and then R is the unknown. So the rate is going to be the unknown. Now I'm going to estimate a rate here for that unknown, and then we're going to use the trial and error to kind of figure that out. That's going to be our method. So I'm going to say 0.05, just picking a rate. I'm going to percentify it, home tab number group, percentify it, then home tab font and underline it. Let's go ahead and sum it up. Equals the sum of these two. 1 plus 0.05. Percentifying that item, home tab numbers percentify, that's going to be 105. We're going to take this then to the number of periods. The number of periods being 3 years. I'm going to make this 5%. I'm going to make that yellow because that's going to be the one that we're going to be solving for. We just made up that number so that we have some calculation. If you leave it at 0, then if you have certain types of equations, it may not, like if you're doing a division problem, that may cause you a problem. So it's best just to plug in a starting point number if you're going to use a trial and error or a goal seek type of method. I'm going to go to the home tab, font, and underline here. Then we'll say this is going to be equal to the 105 to the, or shift 6, caret of 3. And let's add some decimals. Home tab, numbers group, decimalized. And then home tab, font group, underline. And then we can multiply this out. So this is going to be equal to the 4,000 times that number. Okay, so we know what this end number should be now. We know that that end number should be 6,200. The unknown, since they're all linked together here, is going to be this 5%, which we could manually now adjust to say 6%, and then 8%. We could start to test these out until we get to our end number that would be the correct number. I'm going to add a couple decimals, home tab, number, couple decimals. Now in Excel, we can do that manually here, or we could do that with GoalSeek. So let's use the tool of GoalSeek. That's going to be in the data tab up top. The what if analysis and goal seek. We're seeking a goal right here and we're going to find it. So we're going to say set this cell. I want this cell to be, this is how it works, to be 6,200. And then we want to change this 8%, changing the 8%. And then it's just going to do trial and error just like we did to solve for that 8%. So I'm going to say okay. And there it is. It just picks up the number. I'm going to go to the home tab. Numbers, add a couple decimals, so it's about 15.73%. GoalSeek may round to some degree, so it might not be exact, but that'll give us a pretty good number typically within a good range for the GoalSeek usage. So in that way, we basically kind of took the concept of algebra down here, but instead of solving for the equation, instead of solving for R, reworking the equation to be for R, we simply used the same equation in the same format and then used GoalSeek to basically come up with the correct number, knowing what the result should be. That concept could be useful here and is even more useful if we're using a function, because it's quite likely that we're going to say, hey, I don't know the algebra, I know the function, or I don't even want to get into the algebra, right? I just want to use the Excel function here, and the function that I know includes that component as an unknown, but it's not the end result of the function. Is there any way I can use an algebra kind of concept in order to figure out the same number? And yes, you can. What I'm going to do is put in the same thing. I'm going to assume this is 5% here. So we'll say 5%. Then I'm going to use the formula. And when I pick up the percent, I'm going to pick up this percent down here and then adjust this percent using GoalSeek, using trial and error, GoalSeek being trial and error method, to find the percent that will make it work, to make it think what we should be. In essence, kind of doing the algebra, but in a trial and error type of method. So if we do that, we're going to say this is going to be equal to the future value, brackets. We'll pick up the rate, which is the unknown. So I've just made it up 5%. It's best to make it up because if you put 0 there, again, it could sometimes come up with results that don't work. And then the GoalSeek doesn't work if you don't have a good starting point. If it's an NA type of thing, then like you're dividing by 0 or something like that, then it's going to be a problem. So it's good just to pick a number and then go from there. Also, you're going to want the number in a separate cell because you want to refer to that cell as the thing that needs to change in order to change the function to the number that we know it should be. So then we're going to say comma, and number of periods will be 3. I'll pick it up over here. Comma, and then comma, 2 commas because it's not an annuity. And the present value is going to be, we're going to say the 4,000. So there we have it. I'm going to make it a positive number by double clicking on it, going to the end of it before the F, putting a negative sign there, flipping the sign. We know that it should be that 6,200 right there. So we could then just manually change the percent line. And I could say, well, let's make that like 8%. Well, let's try like 12% and so on and so forth. Or we can tell Excel to do that. Say, hey, Excel, would you do that for me? Because it's getting tedious. And Excel's like, yeah, all you got to do is use the goal seek. So then we'll do that. And so we'll go up top and we'll go to the data tab and the what if analysis and goal seek. So within goal seek, we want to set this cell to be this number that we know the end result should be 6200 by changing this yellow number. That's what we're telling Excel to do. And we'll say, do that, Excel. And Excel's like, all right. And then it gives us the 15.73%. There it is once again. Now, this other method, not quite as common, but just to note how you can use this goal seek method over here, you can do this running balance type of calculation as well. So the interest rate is once again what we don't know. I'm going to put that in a cell down below and say 0.05 again, 5% interest. And then if I did a running balance type of table here, it would look something like this. We'd start off with the 4,000, and then after the first period, I would take the 4,000 times the rate, which we don't know, which I just made up down here at 5%. And then we can add this up. This is the 4,000 plus the 200. I could copy that down. So I'm going to double click on this and that rate down here in J3. Is that J7? J7, we don't want that to move. So we're going to make it an absolute reference by selecting F4 on the keyboard, giving us a $sign before the J, $sign before the 7, making it absolute. You only need a mixed reference. Some people get a little picky about that. They think you should, and you probably should, but absolute reference works. And so it's less hard on the noggin. So I'm going to select those two and then autofill them down. There it is. And then once again, I know this end number right here needs to be 6,200. All these cells are connected, and you can see how this goal seek can kind of work as long as everything is connected out and you have just one unknown, even if it's a fairly complex or quite complex set of numbers that are all linked together. So I could do the same thing. I could say, well, what if this was like 9? Or how about 13 and so on? Or we could tell Excel to do it again and say, man, let's just have Excel do this. And Excel, do that for us, please. And we're going to say, Excel's like, all right, it's in the data tab. And then you go to the forecast and the what if analysis, goal seek. And then we're going to say that we want this cell to be 6,200. And we want to do that by changing the percentage cell. And I'm just going to say, okay, do it. And there it is again. And once again, we have that 15.73%. And so let's check it out one more time with the table time. Table time. See if we can back into the number with the tables. So what do we know with the tables? We know that the amount, the starting point we know, which is that 4,000, was it 4,000? And we know the ending point, which is 6,200. What we don't know is the percent. So this amount that we would normally get from the table, we're going to calculate. I'm going to calculate that amount, which is going to be the 4,000 divided by, I'm sorry, hold on a second. It's going to be the 6,200 divided by the 4,000. Adding a couple decimals, home tab, numbers, couple decimals. Let's add like 4 decimals. So that means if I go to my table, I know the number of periods here are 3, and I know that the amount on the table should be 1.55. So if I go to my table, I'd say there's my periods 3, and I'm looking for 1.55. 1.55 in the 3 row. 1.55 in the 3 row is going to be around here it's somewhere between 15 and 16, right? 1.55 between 15 and 16, which is of course what we would expect because it's 15.7. So we know it's between 15 and 16. So you could use some kind of ratios to get a little bit more closer with the tables. Obviously, the tables are not quite as efficient given the limitation of the tables because you can't really have a 15.37 doesn't quite work on the tables. But just note that it's good practice just to get around the tables, understand the tables better, backing into them in this kind of way if you're going to be using the tables, which you probably will or might if taking a course where they're going to force you to use tables and possibly eliminate financial calculators.